Alright, we are doing Unit 6, Part A, number 2A through D. Let's see. So this is given to us. That is the graph of f prime. Part A says find the value of the integral of f prime from 0 to 7. So integrating from 0 to 7 of f prime, you're just adding up the areas, positive 2, negative 7, plus 3, plus 1. So we get our answer. Part B, given f of 4 equals 10. So let's write an expression for f of x that involves an integral. Okay, so we want to, we know that f of 4 is 10. So then f of x is going to be, well, it's the antiderivative of f prime. Focus. Come on. It's antiderivative of prime, but we know the only point that we know is at 4, 10. So we know when we integrate the derivative or the antiderivative, or I guess we're integrating the derivative, we're starting at 4 and we're going somewhere. We don't know where we're going. We could go to the right to 5, we could go backwards to 1. So if we don't know, we're just going to say from 4 to x. And we know also that our starting point at 4 is going to be 10. So that's our initial value is at 10, starting at 4. So then we could do the f prime. If it was, we can't use f prime of x because x is already used. So we'll say t dt. So that's our equation. They asked for an expression of f of x. There's our expression. Use this expression to find the absolute minimum value of f and the absolute maximum value of f on the closed interval from 0 to 7. So remember, we're starting at 4. If we go to the right, we're adding 3 and we're adding 1. So if we started at 10, we got 13, 14 if we go from 4 to 7. So at x equals, I guess we could say at 6, but it doesn't change signs there. So we'll say at x equals 7, we have 10 plus 3 plus 1. So we get 14. Is that a maximum or minimum? We don't know. If we go from 4 to 4, we would be integrating from 4 to 4. We get 0, no area. And we started at 10. So 10 plus 0. So we're at 10. If we went backwards, 4 to 1 is another significant critical point. So at x equals 1, we started at 10, and then we went backwards. We had 7, but since we're going backwards, we're actually adding area if it's below the x-axis. So 10 plus 7 gives you 17. And then at 0, we've got 10 plus 7 is 17, minus 2 is 15. So to answer the question, minimum occurs when x is 4 and the minimum is 10, and the maximum would be 17, and it occurs at x equals 1. All right. C is pretty straightforward. That's B. C is just the integral of g of x dx, where g of x is 5 minus x squared, so the antiderivative would be 5x minus 1/3 x cubed plus c. I think we could do that. And then part D, the most confusing. We want to find the integral from 1 to 2 of x f prime of g of x dx. So it's the integral from 1 to 2 of x f prime of 5 minus x squared dx. Okay, so I'm going to do a subproblem on a different sheet of paper here. Let's say I have, let's say it's an example. From 1 to 4 of 2x square root of x squared plus 1 dx. All right. So this is a u substitution. U is x squared plus 1. Solve for dx. We get du over 2x. So then we'd go integral of 2x square root of u times dx, which is du over 2x. And the 2x's cross off. Integral from 1 to 4 of square root of u du. Okay, so what we do in the way I've taught you is you now back well, actually we have to find the antiderivative. So that's u to the 1 half. So it's u to the 3 halves times 2/3, and we're going from 1 to 4. But this isn't actually true from 1 to 4 because this expression is in terms of u, and our original boundaries of integration were in terms of x from 1 to 4. They're asking from 1 to 4 in terms of x. So that's why we change our u's into x's. So it's 2/3 times x squared plus 1 to the 3 halves. And now we're technically correct. We're going from 1 to 4. Plug in 4, we get 17. So it's 2/3 times 17 to the 3 halves minus plugging in 1, we get 2/3 times 2 to the 3 halves. Okay, we could have probably done that. But you should know that we can evaluate an integral using the boundaries in terms of u. We could have said if u is x squared plus 1, we know x is 1, so when x equals 1, u would be, when x is 1, we can plug 1 in right there, 1 squared plus 1. So when x is 1, u is actually 2. When x is 4, u is actually 17. So at this point here, we did not have to write it in terms of x. We could have left it in terms of u and evaluate it not from 1 to 4, but from 2 to 17. So then I get 2/3 17 to the 3 halves minus 2/3 2 to the 3 halves by plugging in 2 and plugging in 17. And these two answers are the same. Okay, two ways of doing it. Now, 99% of the time, you don't need to change your boundaries of integration. You could just plug it back in terms of x and then evaluate it. But in this problem, going back to the problem at hand, as a dog runs by. Okay, if we look at, if we're going to try to evaluate f from 1 to 2, we can't evaluate it from 1 to 2 because we can't find that exact area under the curve. We can approximate it, but we can't find the exact area. But if we write our integral with boundaries of integration in terms of u, well, let me get there first. So u is 5 minus x squared. So we're from 1 to 2, x f prime of u times dx, which is du over negative 2x. The x's cross off, we get a negative 1/2. So negative 1/2 integral from 1 to 2 of x, f prime of u du. All right, so we're evaluating in terms of u, but these are in terms of x. So how are x and u related? U is equal to 5 minus x squared. So when x is 1, u is 5 minus 1 squared, so 4. And when x is 2, u is 5 minus 2 squared, so u would be 1. So our integral becomes negative 1/2 integral from 4 to 1 of f prime of u du. We're going from 4 to 1, so we're going to switch those. So we're going to integrate from 1 to 4, but if we do that, we have to negate the result. So we make the front negative. Well, it's already negative, so it's now a positive 1/2. Okay, after all of that, we can now evaluate it. What is the integral of f from 1, or of f prime from 1 to 4? From 1 to 4, our integral is negative 7. So we get negative 7/2. Whew. There you go.